So I'm going to talk about how Flutter handles gesture. And first of all, let me introduce myself. My name is Guillaume. I'm the head of the Flutter engineering team at BAM back in Paris, France. And you can find me on Twitter and GitHub and at the coffee break if you want to have a chat. So let's first talk about classic gesture handling in Flutter. You probably all know gesture through one specific widget, which is the gesture detector, which is the higher level API for gesture detection in Flutter. So this is a really powerful API, and show you a bit of example of what you can do with this. You can detect all kind of, I'd say, classic gestures, standard gestures, such as tap, double tap, long press, and all kind of drag gesture in certain direction. And if we look at the whole API of this widget, you have a lot of powerful callbacks to detect all kind of gestures. And so basically, I would say that 95% of the gestures that you need to handle in a mobile app, you can detect with the gesture detector. So that's not what I'm going to talk about today, because you probably already know about this. So what if you need to handle something else? What if you need to handle custom gestures that are not usual and already supported by Flutter? Then I would suggest to go a little deeper and use the raw gesture detector, which is the widget actually used directly by the gesture detector. And its particularity is that this raw gesture detector needs an interface, which is the gesture recognizer. And this interface is implemented by all kinds of gesture recognizer that recognize all the gestures that we've just talked about. So the tap gesture recognizer, the double tap, the long press, and so on and so forth. So each time you think about a gesture that is already handled by Flutter, you probably have a recognizer implemented for this. Now, you probably wonder, how can I make my own gesture recognizer and detect some custom gestures that is not already supported? So to do this, we first have to make a little detour inside Flutter and to see how the detection and recognition flow works within Flutter. So to understand this, first of all, there are two concepts that you need to know about. It's pointers and events. So pointers is basically where you point on your screen, whether it's your finger with a stylus on an iPad or with a mouse on desktop or web applications. And so you have one pointer if you point with one finger, two pointers with two fingers, and it basically stays the same pointer as long as you keep your finger on the screen. And you have another one if you lift your finger and put it back on. So this is pointers. And what you need to know about the events and those pointers is that any gestures that you know about can be decomposed in a sequence of events related to this pointer. So how does this work? You have, first of all, a pointer added event. The first event is just create the pointer and say, OK, is there something happening on your screen? Then you have the pointer down event, which tells Flutter that the pointer is actually touching the screen. Then you might have a pointer move event or several pointer move events, as long as you drag your finger along the screen. And then when you're done, you probably lift your finger, and that generates a pointer up event. And then the pointer disappears with the pointer removed event. So these are all sequences that, these are all events that generates the sequence of any kind of gestures in Flutter. So now that you know about pointer and event, let's see how this goes inside Flutter. Let's imagine we have a pointer event coming on your screen. So we are tapping down on the screen at first. So this pointer event will be handled by the platform dispatcher. That's basically the entry point for any platform-related event in Flutter. And someone is listening to this platform dispatcher, and you might know about this. Mixin is the gesture binding. And the gesture binding is a mixin that is actually used by the Flutter widgets binding that is at the very top of your application. And it has one particular method that interests us here. It's the handle pointer event method. And this is what we're going to dive in to see what it does actually when the pointer event comes in. So the first thing it does is to perform a hit test. So a hit test is a test to understand which widgets on your screen are actually hit by a pointer event. So let's see how it goes. This hit test happens in the render tree. So you probably know that there are 3 trees in Flutter. You have, if you've seen the talk of Craig earlier, for example, you have the widget tree, the element tree, and the render object, the render tree, where render objects live. So this happened in the render object tree. And so I'm not going to talk about widget, but rather render objects. And let's imagine we have this kind of layout. We have a render object with 2 children. One of them has also 2 children. And let's imagine we have incoming a pointer event at that position. So then we perform our hit test. We ask the first widget of the stack, okay, are you hit by this pointer? Meaning, is the pointer within your range, within your frame? So the answer is yes for this one. So we add this render object to the hit test result, and we know that this is responsive to the hit test. Now, we perform the hit test on the second layer to the children of this first responsive. And we also ask, do you respond? One of them only responds because the other one is outside of the range. And we perform the hit test on the last layer. And there you go. We have 3 render objects that have answered true to the hit test. And we have a hit test result of 3 objects that can possibly handle this gesture. So this means that if we come back to our flow, the gesture binding delegates to the render binding the hit test, propagating the hit test all through the tree, and gets at the end a hit test result, which is a list of all hit tested render objects, right? So once we have this, what do we do with this list? We perform the next part of the handling of the pointer event, which is the dispatch event. Now, in the dispatch event, we have this list we just built with the hit test, and we call on every widget that implements that method the handle event method. So we just iterate through the list and call event method. So those render object needs to implement the handle method, which is actually held by the hit test target interface. Now, this interface is basically what allows the gesture binding to call the handle event method. So from this flow, you should be able to implement your own detector. You can create a widget. Then you can, if you've seen the talk of Craig earlier, you can create a widget with a associated render object. And this render object just implements this handle method event. And there you go. You just created some custom gesture detector. But then you have a lot of heavy lifting to do. And I would not recommend to do this, because Flutter helps us a lot in this case. So what does it do? Flutter has a render pointer listener, which actually is inside the render tree. And this is created by the listener widget. And the listener widget is actually the one just used by the raw gesture detector. So, sorry if I lost you here, but we are finally back on our feet. We come back to the raw gesture detector that I talked earlier. And the raw gesture detector finally is going to get the event that is propagating all through your Flutter application. So the raw gesture detector, as I mentioned earlier, uses a gesture recognizer. So it has a list of, well, actually a map of recognizer that we pass it. And when we call handle event on the raw gesture detector, it will call actually the handle pointer down event, because we are at the beginning of our gesture, and we handle this pointer down event by calling on every gesture recognizer a method to register callbacks, so that we can listen to any other event related to that pointer. So this happened in the pointer router. We just add the method, link it to the pointer, and just wait there for any event related to the pointer. And when that happens, when you move on the screen and you get the next pointer move event, for example, then inside the dispatch method, we call one handle event method that is particular, and that's the one implemented by the gesture binding itself. And this one will go all through the pointer router method registered earlier at the beginning of the gesture, and will call the registered method on it. And so at that point, the gesture recognizer is called back with the registered method and can actually do some stuff and handle the event. Now, I grant you that that's not a simple explanation. So let me give you an example of how things look when we actually implement a custom gesture recognizer. So let's do this. To implement a custom gesture recognizer, as I mentioned, we are going to extend we're going to implement the gesture recognizer interface. And you can note that you do not have to directly extend this interface. You can also extend, for example, the pan gesture recognizer and build upon it, so you don't have to reinvent the wheel at that point. So let's do this. So we have a custom gesture recognizer that obviously extends the gesture recognizer. And you need to implement 3 methods: the debug description, that just return some description of the gesture you want to create. And then you have 2 methods, accept gesture and reject gesture, that I will talk about a little later. So for now, we just leave them empty. Now we need to implement another method, which is the out-aloud pointer. And the out-aloud pointer, if you remember from the sorry, I'm coming back to this one. You have this add pointer method just right here at the bottom. And actually, yeah, we will assume that this is the add allowed method on the other slide, because the difference is not much relevant here. So at that point, our gesture recognizer, the pointer event has gone all through the flow and comes down to a gesture recognizer, and it can actually call the add route method and register to the pointer router. So we call the add route method, we pass it the pointer and the handle event callback that we want to be called each time an event comes for this pointer. And this is what happened in the handle event below. You have many move events, for example, between the down and the up events, and you can handle them from that method. And finally, when you're done, sorry, not the right direction, talking about gesture. Finally, when you're done, you can, for example, wait for the pointer up event and then call some callback on your recognizer to let the rest of your application knows that your gesture is over and finally well detected. So there you go. You have a basic row implementation of your gesture recognizer, and you can use it by passing it to your row gesture detector. So you can see the link between the two. That's a whole of boilerplate here, but what you need to pass to the row gesture detector is a map between the type of your custom gesture detector. And what's important here would be the callback that gives the instance of this custom gesture recognizer. And then you can pass the method that we just called at the end of our detected event, so that we can do stuff once we actually detect this gesture. So if we look at some example, here are 2 examples. One is a custom triple tap detector. I'm not sure that's quite useful, but so if we triple tap on this blue square, then we detect a triple tap, and we have a rotation gesture. And I stole this one from the article by Alejandro, so thank you, where it actually extends the scale gesture recognizer and only overlooked all the scaling part and only uses the rotation information. So this is a great example of how to implement a custom gesture recognizer using already implemented ones and not reinvent the wheel. So if you have any good implementation of gesture recognizer that you would like to share, I'd be happy to. So where do we go from now? What happens if we have multiple targets? Now you understand really well how gesture is handled all the way through Flutter, but what if you overlap several targets. And to understand how this works, we need to go through another algorithm, which is we need to come back to the hit testing and understand actually the hit test behavior part. Now, there are three hit test behavior in Flutter. The first one is defer to child. Then you have translucent and opaque. So I'm going to explain those in a little bit. And to do this, I will quote this issue on GitHub about how this test behavior opaque documentation is wrong. And on this issue, which is quite long now, there are great discussions, and there are an answer particular from Hixie, Jan Hickson from Google, and where he explains actually very well how what hit test behaviors are, and he explains it with three questions. The first one is each widget will ask each widget implementing this hit test behavior will ask, should I pass the hit test through to my children? Now, the three behavior will actually answer yes. If we, okay, I'm going to say widget instead of render object because it's quicker. So if a widget should defer to child or be translucent or opaque, in any case, it will always pass the hit test to his children to know what the children answer. So that doesn't help much. So the second question, in this case, in other cases, it can be useful. So the second question is, should I add myself to the list of widgets that were hit? So remember the hit test result list that we created earlier. Should I add myself to this one? Now, translucent and opaque always answer yes. I should add myself. I can be clickable. I am responding to this hit test. But the defer to child will defer to child for this answer and answer the same thing as its child or children. So that's lead us to the third question, which is, should I tell my parent that I consider the hit test to hit me or one of my children? And actually, the parent will stop propagating the hit test if one of their children, okay, that doesn't help you, right? Because here we only have the opaque that always answer yes to this, and the other one also replied the same thing as their children. So I'm suppose that you are very confused by now with the three definitions. That doesn't help you much. So I'm going to give you an example. And I stole this example from the same answer of Hixie. So again, thanks to him. And I tried to put it in a visual way so that you can maybe understand. Let's assume we have a stack widget. And there's an A widget and B widget children. And one of those widgets, the B widget, has a circle that has the opaque test behavior. And now we're going to focus on the hit test behavior for B and see, depending on this hit test behavior, how things happen when we click here, for example. If we receive a pointer event right in the middle on the circle, what happened? Then if the hit test behavior of B is defer to child, then it defers to its child, which is circle, right? And the circle is opaque, so it answers yes to the hit test. So B answers as its child also yes. So they both answer yes, and they both are added to the hit test result. Now, what happens if B is opaque? So I told you that they always forward that to the children, so it forwards to circle, which answers yes, and it also answers yes. So they both answer yes, and we have the same hit test result in this case. And finally, if B is translucent, then it follows to the children, which answers yes. And does it tell its parents that it has been hit of its children? Yes, of course. So the parent does not propagate the hit test, and only B and C are also clicked. So now you're even more confused because I use different kind of behaviors and I always get the same result. So what is happening there? To see the difference, we need to click outside of this opaque circle, because this is the behavior opaque of the circle is what's confusing here. If we click outside with the defer to child behavior, then there's no, the child is not answering true because it's not clicked. So it answers false to the hit test, and so does B. So that leaves us with only A to answer to this particular hit test in this case. If B is opaque, then, well, the circle is never hit in this case, right? Because we're clicking outside of it. So if B is opaque, it tells its parent, I've been clicked, don't tell anybody else. And the parent, the stack, does not tell A that there is a hit test going on, and only B is clicked, right? And finally, if B is translucent, it tells it add itself to the list and say to its parent, no, I've not been hit. You can propagate the hit test. So the stack propagates the hit test, and A also gets hit. And there you have it. There you have the 3 different behaviors actually doing something different depending on where you click on the screen. So now you're telling me we have a certain difference with this during the hit test, but who actually handles the event, right? And to answer this, I need to talk about this object, which is the gesture arena in Flutter, which handles the disambiguation. Who will actually get the event? If I click on a stack with those 2 children, then both recognizer will be added to the gesture arena, and the gesture arena just is one instance on the gesture binding instance, which is every recognizer add itself directly to the arena, and every recognizer, and that's really dark, sorry. Every recognizer can actually resolve this arena saying, I want to handle this event, I need to handle this event. For example, if you're dragging on your screen and the vertical recognizer detects that it's going vertically, then it will say to the gesture arena, hey, you need to resolve. This is going vertically, this is for me. And so the arena resolves itself and rejects all other gestures. So all the other gesture detectors, sorry. And so for example, if you have a horizontal dragging at that point, then it will be rejected, and only the vertical recognizer will be callbacks will be called. So there you go. We only have one winner. What if I need 2 or more? What if I need to handle, I need to understand what's happening on my screen? If I tap on the button, I need to know that somebody tapped on that position on the screen, but I still need the button to be tapped underneath, right? So this way I need to go even deeper and call the listener that we've seen earlier, the listener widget. And this one is called directly by the raw gesture detector. And I come back to Hicks's answer, who gives a great definition between listener and gesture detector. And he says, a difference between gesture detector and listener is that a listener will always report pointers it sees, while gesture detector will fight in an arena, and only one gesture per pointer can win. So there you have the answer. When you use the gesture detector, you have a gesture arena, and then you have only one gesture recognizer that can actually handle the event. So when you use listeners, you can handle any pointer even at any point without interfering with what's underneath. And so you are actually able to handle multiple gestures just like that if you do not use directly the gesture detector. Now, what the usage of the listener looks like. This is a widget, so you pass it child, and then you have some callbacks to use and to actually listen to any event on the life cycle of your pointer during the gesture, and you can do whatever you need to do to directly handle those events and recreate the gesture that you need to detect. So let's see an example. You can also, pass the behavior that we talked about so that you know how it behaves regarding the widget that are laid out behind this one. So if I have an example, if I want to detect gestures upon this scaffold with a floating button, I just wrap it inside the listener, and then if I got a tap at that point on the floating button, then I will get some callback on the callbacks of the listener. So I will get a pointer down. Well, if it's only a tap, not the pointer move, but the pointer up, callback will be called, and I can do whatever I need to recreate my gesture at that point. But I will also get a call on the on-press callback of the floating button, and it works like it should. And it's not dismissed and rejected by the gesture arena at that point, because we use a listener that doesn't know about the gesture arena. So that's good. And to be sure that you believe me, I have an example here. I can detect any gesture, and if I tap on the button, then the button detects the gesture, and then the listener also had detected this tap. So there you have it. We are able to actually detect gestures without interfering with what's behind on our screen, right? So this is exactly what we wanted. Now, the last thing we need to see is how do we test this, all this kind of behavior and implementation that you can do. So to test, you all use the widget tester, and what's interesting here is that it uses a widget controller, which allows you to simulate with a really high-level API test gestures in your test environment. So let's see it in action. If you need to test a tap gesture, to make it quite simple, you can pump any widget. Here I directly use the gesture detector, but any implementation of widget that you have implemented and want to test, you just pump it, pass it a callback on the gesture you need to detect, in this case the tap. And then you can call on the tester, the widget tester, you can call the tap method, pass it the finder to find the widget you want to tap on, and then you verify that your callback has been called once, as expected. What's cool with this is that this tester widget, it provides a high-level API to test custom gestures. So you have the long press, you have dragging a certain widget around along the screen. You can fling, which is rapidly dragging on the screen, and then you can also emulate gestures at location. So you have the counterparts, tap at, long press at, the drag and flick from, so that you can emulate gesture on the screen regardless of the widget that are targeted by the event that you are emulating. So what's the architecture for this? You have the widget controller that offers those high-level method, and they all use behind the scene a create gesture method. We create what's called a test gesture, and on the test gesture, it's really small, but you have methods like down, and then you can move by a certain amount of pixel on your screen. You can move to a position, and then you can call up to complete your gesture. So basically, with this, you are just emulating pointers on your screen, and you can recreate any gesture that you need to test. And so if you decided to implement a gesture recognizer to detect a Z shape, then you can test this behavior easily with this great API, which is a lower level API for emulating tests. And how does this work in the code? Then you have, if you want to test, for example, a vertical drag, and you pump your widget you want to test with callbacks, for example, here on vertical when it's starting, when it updates, and when it ends. Let's say we only update it once. We create a gesture. We started at a certain position. We move by 100 pixels down because we need to detect a vertical gesture. And then we call gesture.up to finish our gesture and says that, to finish the gesture. And we expect the callbacks to have been called 3 times. One when we call start gesture, because this is where the gesture goes down. One when we move by a certain amount of pixels, and then one when we call up. This is because I put 3 times the same callback, but I could test, I could have several callbacks and test it anywhere I want here. So that's really cool. That's really nice because I can really test, I can really emulate and mock any kind of gestures with that simple API. And what's even nicer about this is that the create gesture calls behind the scene the send event to binding method, which calls the test widgets Flutter binding, which is the counterpart of the Flutter widgets binding that we've talked about earlier, which also implements the gesture binding. Well, uses the gesture binding mixin. And this means that all gestures will end up inside the gesture binding mixin and inside the handle pointer event method that we've seen at the beginning. And then you enter the flow that we've seen, and it's just regular gesture handling by Flutter. So that means that any test gesture that you can emulate with this simple API can work and can be tested, can help you test any kind of implementation that you use for implementing gesture detection, whether you use directly a gesture detector, as you've seen on the example, the high-level API, whether you use a raw gesture detector, or even if you implement a listener, then there's just a great separation of concern. Just on one way, you emulate gestures. On the other way, you detect them regardless of how deep you went to implement the detection. So let's wrap this up. If I sum up for you, you have the gesture detector that allows you to detect most usual gesture. So just make an abusive use of this one. It's really powerful. It's really easy to use, and it works in most cases. But if you need to go a little deeper and detect custom gestures that are not available and not handled by the gesture detector, then you can use the raw gesture detector, implement your own gesture recognizer. And if you need to go even deeper and handle multiple gesture, handle a gesture by multiple recognizer that are overlapping on your screen, and things are getting confused with the arena because you're not sure who will get the gesture handling, then you can use the listener, which is the lowest level API for this, and basically you would be able to handle your gesture without interfering with what's behind, as we've seen. And finally, what's great is that the widget tester can help you test all those implementation regardless of what you use, and that you have very high-level APIs so that your tests are really neat and clean, and you have lower-level API to implement custom gestures, so you can really play with this and test however you want. That's really cool. So here are some useful links for you if you're interested in gesture detection and you want to go a little deeper. I recommend the gesture binding documentation, which explains really well how things works inside the gesture detection flow that we've seen, not with all the boxes and arrows. But it's really nice. You have the gesture disambiguation documentation that explains how the gesture arena works and why they're one winner and who will win when we have several gestures in the same arena. I added the link to this issue that I mentioned 3 times in the talk, so because it's a really interesting issue, and you have especially Hicks's answer that gives a really good insight on how the hit test behavior works. And finally, I made this repository, gesture handling sandbox, that you can go if you want to see examples, sandbox. If you need to understand things about gesture that you did not after this presentation, then you can just clone this repository and play around with things, see how it works, and if it doesn't, just reach out and let me know. I'd be really glad to help you to check this with you, because yeah, that's really interesting for me. Thank you very much. You can reach out to me on Twitter and GitHub, as I said, and I hope that you have a very nice conference, FlutterViking, and thanks for having me.